We will create a new project by clicking on New button here. We will get this dialog box. SEG includes some of modules for static equipment, for horizontal pressure vessels, vertical pressure vessels and columns, heat exchangers, ducts, storage tanks with fixed roof, spherical tanks, and pipe. Now we will select a name or write a name for our project and select the location. Now we will select the type of the project, which module those. By selecting the overall module, you will get all features inside those modules. For example, in heat exchanger, you will find the expansion joint tube sheets. But if you select pressure vessels, you will find this those features. The same for storage tanks. In storage tanks, you will find the roof plates, bottom plates, annular plates. If you select the pressure vessel, for example, you will not find those features. In case of selecting overall, all features for all modules will appear. Now we will click Finish to start creating our project. Here, as you can figure, the project tree includes two levels right now. The first level is the project level. In the project level, we will define some information regarding to our project. Those information will appear on the drawing and the title block of the drawing, like the project name, plant name, client, owner, location, manufacturer, all of that. And the second level is the equipment level. In the equipment level, we can make a rename for the equipment by renaming it and defining the design data of this equipment, like the construction design code, internal design pressure, temperature, external design pressure and the temperature, maximum allowable. And if you would like to modify on those values, you can modify by double-clicking on the cell itself and modify the values. If you would like to remove all of those checkboxes by deselecting all checkboxes and select the required fields only like that and modify the values. If you have those values in an external Excel sheet, you can import it from Excel sheet directly to this form. Okay, so for the design data, you have three ways to modify. The first one, by modifying it directly, by double-clicking on the cell and modify the value. The second way, by adding new rows to add new values. The third way, by importing an Excel sheet. On the same level of the equipment level, if we open the setting tab and open the equipment setting, you have the ability to modify some settings for this equipment, like the position of the equipment. If you would like to make it horizontal, sloped, or vertical, so you can change the orientation of the vessel. Direction of the assembly. In the horizontal and the sloped case, you can start the assembly from left direction to the right direction, or from right to left, the assembly direction. In case of vertical vessel, if we select the vertical vessel, you can start your assembly from bottom to top or from top to bottom. So you can change the position of the vessel and the direction of the assembly. In case of sloped vessel, you can define the sloped angle of the equipment. Regarding to units, you can make your project in millimeter units or in inches. Here, another value for the delivered blade dimensions. Those values are very important because they are used to calculate the required number of blades in the same shell force. For example, if you have a large diameter vessel, let's say 5 meters, for example, and the available blade in your stock is 7 meters by 1.5 meter. Okay, so if you calculate the required number of sheets, so from here, if we define the diameter of the shell as 5 meters, the total circumference of the shell will be around 16 meters. In this case, one blade will not be enough to make the total circumference of the shell. So automatically SEG will detect the required number of sheets. In this case, they will be 2 complete sheets and 1 not complete sheet. That means they will be 3 sheets on the shell. Okay, so those values are very important here, the delivered blade length and the delivered blade width. Okay, so we should define those values in a correct way, or on the actual, in our case, in our project, to be sure that SEG will calculate the required values. Now we will start creating a new vessel, a horizontal vessel. So let's add the first element, which is an ellipsoidal head. So from here we will add a left head. Okay, click enter. Now we will select this head, and from here you will find a list for the type of the heads. If you take a look at this list, you will find more than 17 types of heads. The first type of head is the ellipsoidal head, which is a half of ellipse, not including any crown or knuckle radius. The second type is ellipsoidal head with crown and knuckle radius, like that, not a half ellipse. A flat dashed head, and some other different types like standard cab, diffuser head, convex head, flat head, hemispherical head with negative straight flange, which used in division 2, cone head with neck at the end, closed cone, and circular flat end and hold. So let's select an ellipsoidal head and define the inside diameter of this head, 2 meters 0.5. The thickness, let's keep it 10 millimeters. Define the straight flange, the minimum thickness after forming, the ratio of the head. And if you would like to define the material of this head regarding to ASME section 2 part D, we will open this button, and from here we will select the table of the material according to ASME section 2 part D and make a search for our material. So let's write the material here. Okay, now you can figure that the list is become minimized. If we write it like that, you will get the all grades of this material, which is 516. So we will select this grade, and if you would like to make it impact tested or normalized, just select the checkbox. And if you would like to define the material manually, you can modify it directly and by making the text from here. One more option on the same head itself, you can make it from one piece like this, as created from one plate. And if you would like to make it from 2 pieces, including a welding line like this, you can select 2 pieces. And if you would like to make it from more than 1 piece by making it from segments, just select the suitable type for your case and click save. Now let's click on start assembly to create the assembly on Autodesk Inventor. Okay, now we will create a shell course. So from here, let's add CAN1. And from here, you can figure that SEG includes many types of shells, like shell as a pipe, or shell as a plate but without any welding lines. Actually, you can use this type in case if you would like to make a quick review for the weights. So you don't want to make different shell plates. Like if you have an LBG with 40 meters length, and you would like to make it as a one piece to calculate the weight, for example. So you can use this type in this case without any welding lines, because you would like to make something fast, not in detail. this shell type, including a welding line, and in this type, SEG automatically calculates the required number of segments, and if you would like to modify it manually, you can define the number of segments directly from here. Another different types like shell from different pieces. This type usually used for the storage tanks, and the other types here like different pieces and thicknesses. In case of storage tanks, you can define different shell plates with different thicknesses. Like if you have a clean outdoor, this clean outdoor needs another thickness for the shell blade, not looks like the other blades on the same shell course. So you can use this type of shell, which is shell from different pieces and thicknesses. Now let's define the select the shell type and define the inside diameter, define the length of the shell, the welding gap, and let's click save. Now if we click on assembly, the information will be sent to Autodesk Inventor. Now let's create some other items like CAN2, and in this case we will make CAN2 looks like CAN1 to avoid repeating the information again. Okay, so if we click on add and if we select CAN2, you can figure that the same data get from CAN1 to CAN2. Now we will change the orientation welding line only. Okay, and let's add another CAN, and let's make it looks like CAN1. And now we will add the last head, and let's make it looks like the left head. Now if we click add and select the right head, you can figure out that the same data for left head come right here. Now another more option here for the flipped direction, which gives the head and some other items like flanges flip the direction of the head. Right now let's create the assembly to figure out how this checkbox will affect on the model. Here that's the third shell course and the last piece, which is the right head. Now if we take a section on this model, so let's take a half section, you can figure out that the direction of the head becomes the same of the left head. Okay, so to flip the direction of this head, so you can figure out that the same direction of this head, we will need to flip it. So from flip here, so let's select flipped option and click save to flip the direction of this head to be like that. Okay, now let's add some attachments to this vessel, like some nozzles. Okay, and support saddles. So from here, let's just select the left head, and from here, let's select N1. And you can figure that there are many types of nozzles available for the nozzles on head, like nozzle from pipe, nozzle from plate, long weld neck, self-reinforcement long weld neck, standard forged hub or self-reinforcement forged hub, integral nozzle or self-reinforcement integral nozzle. So let's select a nozzle from pipe and select the size 24 and with a rebad with width 200 millimeters and the thickness. Change the schedule of the pipe, change the offset and make it on 190 degrees and make it as Manway, and let's click save. Now let's add a flange for this nozzle and one flange here. So let's select the type of the flange. As you can figure, you have many type of flanges like long weld necks, slip-on, threaded, lap joint, RTJ, rigid face according to S, maybe 16.5 or 47 series A or B, many different type of flanges. So you will select the suitable type for your case, select the rating, size and schedule of this flange, the material, and click save. Now if we come back to the nozzle, here from the calculator, if you would like to calculate the projection of the nozzle from the facing of the flange to the seam line of this head, so let's make it 1500, and by clicking on calculate, SEG will make a sketch and calculate the projection for this one and let you know that the projection to the face of the flange will be like that. So let's minimize this value to be 1 meter and recalculate the projection here. So that's the projection of the pipe from the outside surface of the head. So let's click save. Now, if we would like to define the welding detail for this head, by clicking on set weld, we will open this form and select if you would like to make it single V or double V, and define the weld fillet, which is dimension A here, which is the fillet between the pipe and rebad, and dimension B, the fillet between the rebad and the shell, and click save. Now we click on the assembly and come back to the model. Here, as you can see, the assembly of the nozzle running on behind. If you would like to make a rendering for the assembly of elements during creation, I will show you an option, give you the ability to make a rendering for element during creation. Here, you can figure that we have this nozzle, which is M1, with an offset from the center line and the projection as we defined from the seam line. Now, so let's make an option for the preview of elements during creation. So from here, we will make a preview or rendering for elements during creation for parent elements and child. And now let's add a saddle on the first shell. So let's add a left saddle here. As you can figure, we have 12 types of saddles. You can select the suitable type for your case. So let's select this type, define the contact angle, the thickness, the fillet of the rebad, and base plate length, width. Here we have 4 holes and the location. Okay, and here the height. And if you would like to minimize the web width, if you take a look to the image on the right hand side, the value which is BW, which is the bottom width of the web, you have the ability to control it. If you would like to make it a straight with the straight sides, so the sides will be perpendicular to the base plate, you will select this checkbox to make it with the straight sides. If you would like to make it with a defined value, narrow or wide, you will define this value from here. And if you would like to make a cut on the web, you can make a cut from here. So let's add an outer ribs, and let's add a mid rib, and let's click save. Now if we click assembly, the rendering for the saddle or the saddle assembly will be on front of us, because we select the option of preview or rendering of elements during creation. Okay, now the elements of the saddle are running. Okay, we make all holes on one side, and if you would like to modify it. So we need to change the location of the saddle. I think we make it on 100 only. So we will make it on 1000 instead of 100, and make the number or the number of the holes divided in 2 rows. So we will make it a second row, and let's click save. Now let's add another saddle. So from here, let's add right saddle. Okay, and let's make it looks like the left saddle to avoid repeating the data again. And just we will change the location of this one. And from here, we will make it as a sliding saddle and define the slot length. And let's click save. Now, if we click assembly, it will be updated. The first saddle location will be changed. After that, the second saddle assembly will start. It will be the same dimensions of the first saddle, but as we mentioned, we change the location and the type of hole, make it as a slot hole instead of straight hole. Okay, now we have the assembly of the those saddles here, and you can figure that this saddle was slot holes, but the other one with straight holes. Now let's add a Davit to this Manway. So from here, let's add a gasket. So from here, let's add a gasket from other N1 gasket. And you can figure that many different type of gaskets. So let's select the suitable one, which is the resin face gasket according to ASME V16.5. Define the material and click save. Let's add a blind. And from here, we will select raise the face blind according to ASME, select the size, and we will flip the flange to make the raised face on the facing of the gasket. So let's click on save and simply. Okay, now as you can figure that we have this Manway. Now let's add some attachments to this Manway, like hand grip, stud bolts, and depth. Okay, so from here, let's add hand grip in one grip. And from here, let's define the length, which according to this image on the right hand side. And from here, let's define the number of hand grips. We need 2 hand grips, and click on simply. Okay, now we have those 2 hand grips, and let's measure the required length for the bolt, the spacing for the stud bolt. So let's add stud bolt. Click Save and start the assembly. Three stud assembly, one stud bolt and two nuts, like that. And it will be assembled with the blind, like that. Okay. Now, if we, for example, if we open the bill of material to check out the bill of material created by SEG, you can figure that we have two ellipsoidal heads, okay, and three shell courses with the same length, width, and thickness, flanges, and here the stud bolts required and nuts required for the Manway. Okay, for the Davit, if we select the blind flange and check out the attachments that we can add it to the blind, like nozzles with external projection, nozzle with external and internal projection, lifting lugs, hand grip, and Manway Davit, and the detailed Manway Davit. Which what is the difference between this Davit and that one? The first one, which is Manway Davit, it's a Davit not in detail. You will not get a detailed bill of material for it. Okay, but this one, it will appear on the bill of material as a one part. Okay, so let's add it and check it in one Davit. Okay, so you can figure that you have many different types. So let's select the suitable type, which is that type, for example, and let's make it on 0 degree, and let's click on assembly. As you can figure, it will appear as a one part, not in detail. And if we check the bill of material, it will appear as a one part. Okay, so we need to change the orientation of this one. So let's make it like this. But right now, if we open the bill of material, you can figure that the Davit is a one part. Okay, so this Davit is one part, Manway Davit time G. Check detailed drawing, and that's the weight of this estimated Davit. But if you would like to get this Davit in detail, so let's add another type of Davit, which is Davit in detail. So let's select N1 Davit B, and from here let's select this type of Davit. It's according to shell standard. So if you would like to add another standard to SEG library, just contact our technical team and give us the information, and we will convert it to a database and create this type or this standard, this spec, and add it to SEG library to be able to use it anytime. So let's select this type, and from here let's select the rating, the size, and the orientation of the Manway. Select the type of the flange. If it's weld neck or slip-on flange, just select the checkbox. Change the direction of the opening. And if you would like to modify the dimensions manually, just click on user-defined dimension to be able to define those dimensions manually by hand. Okay, so let's click on Save and click the Assembly button. To start creating, that's the first Davit, because we changed the orientation of this Davit. After that, the detailed Davit will start. Here, that's the assembly of the detailed Davit, and as you can figure, element by element will be imported to the assembly and assembled automatically. That's the second element. Like the saddle and nozzle assembly, it's assembly from parts. So this Davit is assembly from parts, and you can figure out that each element of those will be modified according to the standard of the shell. After that, it will be assembled to the model. As you can figure, it takes a time because it's not a huge time. It's just maybe 1 minute. But if you compare it with the Davit as a one element, the Davit was as a one element, you will not get a bill of material for it. You can use this Davit in case of if you have a larger model and you would like to make it fast little bit, and you can make this Davit for one nozzle only and make a detail for it, and keep the other Davits as a one part. And if you would like to make it in detail, you will be able to use this type of Davit to make it to give you the ability to make a bill of material for this Davit in detail. Now this Davit is done. Okay. Now if we take a look at this, you have this detailed Davit according to shell standard, like that. As you can figure, here we select the type of the type flange B, which is the slip-on flange, so the weld neck flange. So I should select this type, which is type flange B, which is weld neck flange, not slip-on flange, to make the value of B is greater than. So let's check the value of B dimension A and B. You can figure that it's 165 for slip-on, and it's 230 for the type B, which is the long weld neck. So let's select this checkbox and click Save, and let's delete this Davit from here, the Davit as a one element. Let's delete it and keep the Davit with as a detailed Davit, and let's click simply to update this Davit. Now we update this Davit, and you can figure that the lug come back again to suits the saddle, to suits the weld neck flange location. Okay, so by this way you can make a detailed Davit, and if we come back to the table again and open the bill of material, you can figure out that we have here one bolt, a washer, 3 nuts, eye bolt, Davit arm, and here all of the detail of the Davit. Okay, in with the bill of material. Now let's add another element to the shell. Like we need to make a boot, for example, on this shell. So let's add a boot. So let's add a nozzle, and let's make it from blade. Okay, and let's define the diameter to be as a 1 meter, and let's add a rebag to this one. Okay, and let's make the location. Okay, the orientation 190 degrees, and let's make the projection. So let's calculate the projection. We need to make the seam line of this nozzle from the from the vessel center line. So let's make it 3 meters and calculate. Now that's the projection required. So let's minimize this little bit and calculate. Now that's good. Let's save this one, and from here let's open the set weld and define the weld details for this boot and click save. Now let's add a bottom head for this boot or some head. Okay, so let's select this head and select ellipsoid head, define the inside diameter, the thickness, and the straight flange, and make it flipped. But let's check this one here. That's the pipe OD, not the pipe inside diameter. Okay, so for the head, we will change this value to be like that. That's the inside diameter, and let's click start simply. Here we have this nozzle from plate and the weir plate. The bottom head. Now we have this boot like that, and let's change the location of this boot a little bit to go far from the welding line right here. And by the way, if you would like to get sheet metal flat pattern for this element, for example, get the flat pattern, you can get the sheet metal flat pattern for the sheet plates like that. So that's the contour of cutting to get this this pipe of plate. Okay, the same for the weir plate. If you would like to get the sheet metal flat pattern for this one, you can get it directly. And there is an automation tool here, can get all sheet plates for your project at the same time. Now let's change the location of this one a little bit. So let's move it back a little bit, and let's add a nozzle to this sum head. So from here, let's add N2. Okay, and so let's select it as a long weld neck nozzle. Find the size. Okay, and the offset from the center line is 0. And let's click save and define the projection. Let's keep this value. Okay, and drain. Let's click save, and now let's define the fillet weld, and let's click on assembly. To change the location of the nozzle at the first, after that creating another nozzle to the sum head. Okay, now you can figure that we add some attachments here, and if we take a look to SEG components, here if we select the shell, for example, you can add a different type of supports. This is the supports group. You can add saddle, and as we discussed, the saddle includes 12 types of saddles, and let's come here. Here, there are main 4 types of the saddle. The first type is the saddle with the width of the saddle with edges without any straight edges like this or that without lifting lug, and you have the ability to add outside trips. The second type of saddle, you can make the width with straight edge like this, goes to the center of the vessel. The third type is the saddle, the width saddle including a straight edge perpendicular to the base plate like this edge, and you have the ability to control the length of this. The fourth type is saddle with a lifting lug. In each type of those saddles, we have three sub types. The first one is the width be located on the left side or in the mid side or on the right side. You have the ability to control the bottom width of the whip if you would like to make it with the straight sides as we discussed, or make it narrow or wide like this. So that's the first type. The same options for the second type, which is the whip with straight edge like that, goes to the center of the vessel. You can make the whip on the left, right, or on the middle. You have the ability to control the bottom width of the whip. You can make it with the straight sides like that, or with a narrow or wide. The same for the third type with straight edges perpendicular to the base plate like that one. The same options for the whip location and the bottom width of the whip. The fourth type for the saddle with lifting lugs. Another options like if you would like to make a cut on the whip, in some specs it may require a cut on the whip to suit the tightening of the anchor bolts, because this area sometimes become narrow, so you need to make a cut on the whip to be able to make a tight for the nuts. Here some specs include this cut. If you would like to make a slot hole or straight hole or without holes, some specs include the sliding saddle without any holes by fixing it with two flipped angles or by another way from the sides and Teflon below to make it slide, and no anchor bolts in this saddle. So if you would like to make a saddle without any holes, you have an option to make that. You can control the direction of holes. You can make it on the short direction or you can make it on the long direction. You have the ability to control the number of reps of the saddle up to 9 reps per saddle. For the lifting lugs, SEG includes many different types of lifting lugs to suit your requirements. Those types available for the shell. We take a look to the first type. This type of lifting lug, you have the ability to control the location of this hole. You have the ability to add a wear plate, so it's an optional to add a wear plate or add a cooler. Okay, so this type is a longitudinal direction, the same shape but on the circumference direction like that. You have the ability to add a wear plate and cooler, control the location of the hole. This type of lifting lugs usually used in the mid-range weight vessels. This type of lifting lugs for large weights of the horizontal vessels. It's available. It's not common, but it's available in SEG. This type is common for vertical vessels. You can figure that in the same type, you have the ability to make the end with a round or with a chamfer. You can make the lug with a straight end like this or with a cut, and you can make this cut with fillets or with sharp edges like this. You have the ability to add a cooler and wear plate. It's an option. This type of lifting lug for small sizes and usually used in heat exchangers for bonnet and shell channel side. The same type in circumference direction. You can make it with a chamfer or fillet. This type of lifting lugs with two support ribs like this. Cross type, it's usually common in case of lifting from single point, so you can use this type of lifting lug. Trunnion. In the trunnion, you have the ability to add end plate like this. It's an optional, or you can remove it. You have the ability to add a ring or make it 2 rings on the outside. For the inside ring, you have the ability to remove it or add a 1 ring or 2 rings like this. So many different options on this type of trunnion. This type of trunnion usually used for vertical or horizontal bezels in mid-range. So you can figure that in SEG you will find many different types and options for the saddles. And let's take a look on the nozzles. In SEG for the shell nozzles, it's include around 23 types of nozzles. Those are the common types of nozzles, like nozzle from pipe, nozzle from blade, long weld neck nozzle according to ASME or PSEN, long weld neck with self-reinforcement, long weld neck without flange, forged hub, self-reinforced forged hub, integral hub, self-reinforced integral hub, rectangular opening, oval opening. All of those nozzles include the radial, helicide, tilted options, and you have the ability to add insert pad or rebad tool. So many different options on nozzles. The same for the supports, as we discussed the saddle, stacked saddle for heat exchanger, skirt, legs, lugs, ankle chair, support, a leg like this, cradles, many different types of cradles. We come back to SEG here. Many different type of openings like nozzles with internal and external projection, nozzles according to ABI and couplings, clean outdoors, weld outlet, stun outlet coupling. And for external attachments, you can add a main plate, external background lug fireproofing, external stiffening rings, ladder clips, insulation rings, platform clips, cladding, spiral rings. And for the internal, you have the ability to add impingement baffles, deflectors, demister, trays, baffles, cross beams, vortex breakers, piping support for the platform and coil and half pipe. Those are the elements that you can add it on the shell. If we take a look on the head, for example, you have the ability to add skirt, support pipe as a leg, support pipe from beam, nozzles with external projection, nozzles with internal projection, weld outlet couplings, coupling nozzles, stub outlet, impingement plates, vortex breakers, pass partition, cladding, insulation clips, lifting lugs, different type of lifting. Now let's make a drawing for this equipment. Before start creating the drawing, let's check the bill of material. That's the bill of material created automatically. And as you can figure, that SEG detected that there are 2 identical items from this elliptical head and sum them in one element. The same for shell course. Here for the ribs of the saddle, the wear plate of the saddle, nuts and bolts. So SEG take care about this. If we open the nozzle table, you can figure that we add 3 nozzles. The first nozzle is N1. It's a Manway, 24 inches. The outside diameter, orientation, thickness, scalable. The flange rating, the connected flange rating. The facing of the type of the flange, it's include blind. That's the rating of the blind. The rating, the facing of the blind, projection of the nozzle, rebad thickness, rebad width, the welding style, and the welding details, fillet width. So the nozzle table includes a lot of information that we defined for the nozzle. And if we open the flange table, you can find that we have those type of flanges. And if we now we can start creating the drawing. Before this step, we need to make update item number, because this step is very important to reflect the item number of elements to each element. As we discussed, SEG detect the identical items and sum them in one element. For example, for the ellipsoidal head, SEG detected that we have two ellipsoidal heads. They are identical, the same weight, the same material, the same information. So SEG sums them as a one element, and quantity is 2. Okay, so they take item number, the same item number, which is 1 in this case. So by clicking on update item number, we will reflect this calculated item number to each element created on Autodesk Inventor. This step is very important before starting the drawing, because if you would like to add a balloon to elements, this balloon includes the item number in bill of material. To reflect this value, you should make this step first. Now let's create the drawing. And before this step, let's discuss this point here. If you would like to import your standard format to SEG to use it as a reference drawing, you will import your reference drawing from here. After that, define some values to make the default value or the default template included here, so you can use it anytime you will create your drawing. Now it's this template related to one of our customers, so we will delete it to use our reference template, which is SEG template, and let's click yes. Now let's start creating drawing. So from here we will select create drawing. From here we will select the size of the drawing, the orientation of the drawing, if you would like to make it landscape or portrait. Define the location of the title block, and from here we will define the elevation. We need 2 views, and we will make the spacing between views by 3 centimeters. Okay, and from here we will select the elevation view orientation. That means here, if we take a look to this view of the equipment from the back view here, so if we select the back view, that will be the elevation. So that's the elevation, okay? And the orientation of the elevation, if we select it back, it will look like that on the drawing. And if we select left, it will be like that on the drawing. So let's select left and define the location of this equipment. Define the scale of the equipment, and from tables let's select bill of material table, design data table, and nozzle table, and let's add client and client document list and vessel document list. And from here, that's the nodes. If you would like to add nodes, you can add it. After that, click on add, and if you would like to edit, just select the row and click add. Okay, and if you would like to import from Excel sheet, just select from here the Excel sheet. For the welding details, you will open the SEG standard library and select the required welding details to import it to your drawing. So let's select this one and that one. So that's the library of welding details, and let's click save. Now for the title block, we will make it general arrangement drawing. Okay, and let's define the revision table. Okay, and let's click add. Let's add some empty rows, and from here, if you would like to make the general sheet includes 2 subsheets, you can make it including another subsheet or third subsheet. So right now, let's click on create to start creating the general arrangement drawing of the equipment. Here, as you can figure, the revision table is filled and is automatically. The same here for the bill of material. Now it's filled, and it will be updated and takes place takes the correct place on the drawing. The same for the design data that we imported, updated and takes the correct location, the notes, the nozzle table, here the client document list and vessel document list. Now the building details will be created to the drawing. Okay, now we need to increase the scale of this vessel a little bit and move it a little bit to the left hand side. So let's come back to the drawing, and from here on the create drawing, let's select the orientation. So let's minimize the location here and increase the scale a little bit and click on create. So we may need to increase it a little bit. So again, from drawing and from here 24 and click create. Okay, I think this scale is okay. Now let's add some annotations and some center lines to the vessel. The 10 lines here. Okay, now let's measure the values that we defined for the nozzle offset. That's the nozzle offset as we defined here. If we take a look to the manhole, so that's the offset that we defined and the orientation. Okay, and the projection as we calculate is 1 meter from the seam line. So if we measure it from here, so let's come back and measure the projection from the facing of the nozzle to the seam line. It will be 1 meter. Okay. The same for the projection of this nozzle. We will make it 2 meter 0.5. So if we come back to this nozzle and check the projection, it will be 2 meters 0.5. So by that way, you can let's add the shell courses length like that, the tan line, straight flange, so let's add text for that. And let's copy properties to this one. Let's add the inside diameter of the vessel. Okay, that's the inside diameter. Let's add the nozzle balloon. So let's select this nozzle, and from here let's select parts only, and you can figure that you will get the nozzle balloon from here the same way. That's nozzle N2, and if we select as attach balloon and select this one, that's the blue nozzle. And if you would like to add some dimensions like that, just in seconds you will get all of your dimensions. Like that. And if you would like to add some annotations like the bill of material item number, which we discussed, like that. So let's check item number 1. If we come back to the bill of material, item number 1 here is an ellipsoidal head. And that's the definition or the technical characteristics of this element. It's an ellipsoidal head 2 by 1. That's the inside diameter, thickness, minimum thickness after forming as a straight flange, the material and the weight of this element, and we have two elements from this ellipsoidal head. Let's check item number 9. So here, item number 9, it's a seamless pipe, and that's the definition of this pipe. Its NB is 24, scalable 14, and that's the length, the material, and the weight of this element. Let's check this item number, which is 14. So let's go to item number 14. It's a rib plate. We have 4 ribs. Okay, the length here, width and thickness, and the weight of this element. If you would like to make another detail here, like if you would like to add the saddles here, for example, if you would like to add the saddle, and I will show you how to make a separate drawing for the saddle by the same way. So let's come here and add this saddle detail. If you would like to add a saddle detail here, like that. Okay. So if you would like to add a detail for the saddle and take a section for from here to there, for example, like that. And if you would like to make a detail for this hole, slot hole, like that. Okay. So you can add those dimensions later, but by this way you can create a detail for the saddle on the same drawing if you would like to make a lot of details on the same drawing. But if you would like to make a detail for this saddle separately, by the same way we will select the element, and from drawing we will click on create drawing, select the drawing size, select the elevation view, define the spacing between views, select the saddle elevation view. So if we come back here, if we take a look from the left view to this saddle, it will look like that as the elevation. But we would like to take a look to this saddle from the back view, so we will select the back view to be the elevation. Define the scale, orientation. Let's add a bill of material. Okay, and from here let's add a saddle detail. Sorry. Okay. And from here let's edit this. Let's save, and let's add some other empty rows, and let's create a drawing for the saddle. That's the revision table, the bill of material. Now let's change the scale a little bit to suit this drawing. So from drawing, we will change the scale. So let's make it 14, and let's click create. Okay, now let's add some dimensions to this saddle. The contact angle, and the saddle contact angle, the thickness of the base wear plate, the thickness of ribs, the height from let's add a center line first, and let's measure from here to the base plate length, base plate width, like that. By that way you can add the dimensions and the welding details. So if you would like to add a weld detail right here, modify that way, automatically done. The shell and head. So with the saddle and the shell, it will be like that. And if you would like to take a sections to define the base plate and other items, you can make it by the same way. Okay, that's for a quick demo. And after your questions, I will show you some projects created by SEG Software, complete projects for some of our customers. So if you have any questions right now, we can discuss it.
Any questions?
Yeah, hello. Hi. Hello.
Yeah, hi sir.
Can you hear me?
Yes, yes.
Okay. That's a fantastic demonstration of this software. I think you have filled the gap between design and the drawing, which people are really struggling with. So congratulations for that. And few questions, quick questions. First thing is that which version of this inventor we are having 2016 with us, whether this will support 2016 inventor?
Yes, it supports Autodesk Inventor 2016, but you will miss some features. Like if you would like to make a nozzle holing or a tube pattern assembly, you will not be able to create it. You will need Autodesk Inventor 2019. So 2016 it will make everything run, but except those two options. Here there is an option for the nozzle opening. If you would like to make an opening or the nozzle opening of the shell blades, you will not be able to create it on 2016.
Okay.
The second option for if you would like to make a tube sheet and make a hole pattern and a tube bundle assembly, you will not be able to make the tube bundle assembly. Except that you will be able to run it.
Okay, because 2016 up till 2016 they were providing some perpetual licenses.
Yes,
now they have gone to subscription.
Annual license subscription.
Yeah. So okay, there's one question, and now about this materials. When we change the material, whether it can give us the weight as per the material selected, or how it is. If I'm selecting some other material like brass or bronze, so it will take the density as accordingly.
Okay.
The density of the material.
If you would like to modify this to get the accurate density or the accurate density for the material, you can make it for the elements that includes the another material. Like let's for example, if we have, let's say this not from steel. So if you would like to change the density of this one, so from here let's open the material itself. So as you can figure, it's a 105. So if you would like to define the specific gravity manually, you can change it from here from the physical properties and change the density. You can figure that's the density of steel. But if you would like to change it manually, you can change it from here, and directly it will be reflected in SEG, because SEG will give the correct weight of this element depending on the specific gravity.
Okay. So this is was one question, and this can we add some other standard into the database what you have prepared in the existing SEG software, like Davit, like Davit. If you are having some different type of Davit and you want to
Davit, for example, as we discussed on this demo, you can send us the data for this Davit, and we will include it to this option is for free. You can send us the database, or not the database, you can send us the PDF, which includes the standard dimensions of this Davit with different sizes, and we will add it to the SEG library to be able to use it on the next project or the next project.
This software has whatever any request will be there, the development will be made by the team from Ahmed. So based on whatever data you guys are going to share, so software will also going to get developed based on the inputs what we will be sharing. So it is not
But for
just
in some case, yeah, for some case, what happened that is one-time use. That the standard is not applicable always. So just
yeah,
one time we are using it. So I think we can create that in this inventor and then put it
correct.
there.
Yeah.
That can be
You,
also
you
done.
can also create or you can tell Ahmed team to do that for
Mm.
you, but that will take some 15 days minimum time, I believe.
That is what the
And,
problem is
yeah.
because you know how much time client is giving us. So that is
I
the
know, I know.
problem.
Okay,
Yeah.
regarding to
So
this point, you can add any item to the assembly by hand. If you have a special item like and a special internal, uh,
okay.
and you create it on Autodesk Inventor, you can add it to the model and reflect it to the SEG bill of material to make it appears
Okay.
on the drawing. Here from the
Okay.
table, if you open the bill of material, you can find that here an option for the extra bill of material. From here, you will select the bezel and define the new item. Okay,
Okay.
and if you save it, it will appear on the SEG bill of material here, and it will be
Mm.
reflected to the drawing. Okay,
Mm.
so
Okay.
if you would like to add a quick element you created by hand, you can add it directly to the bill of material. Okay, but it's not
Okay.
to SEG library, just to make it appear
Okay.
on your drawing in bill of material.
So that will come as a one object. One
Yes, as a one.
object that this will
Yeah.
come. Okay.
You can add more than one option. For example, let's add item 30. We have 5 minutes description, technical characteristics, material, weight, part D, marks, and let's save. We close here and open it again. You can figure that that's the item that we had.
Yeah.
And if you would
Okay.
like to make a modification on it, you can make an update. And if you would like to add another one, 31, 1, 2, 2. If we close and open it again, you can figure that we have those items. And if we make update to the bill of material, so let's update this table to the drawing, okay, to reflect those values to the drawing. Here, as you can figure, the bill of material ended up to 29. So let's make an update for the bill of material. So from here, let's come back to the drawing and click on create drawing. And from tables and annotation, let's remove all of those tables and keep the bill of material. We need to update the bill of material only and click on update tables automatically
Okay.
to update the bill of material. And by clicking on create, sorry, you will figure that
Okay.
the bill of material will be re-updated again. You can figure that the values will be deleted and refilled again according to your updates. Here, let's move it up a little bit. And you can figure that we have the new items here appear again.
Okay.
Okay,
So it will be added in the total weight as well.
it will be added to the bill of material and the drawing by that.
Okay. And how about this operating weight? If the vessel is full with liquid, partially filled with liquid, and we want to have a operating weight of that, whether we can get this from the software?
Okay, right now this option is not included, but we will work on it in our plans to calculate the liquid inside the element. But you can make it roughly. For example, if you would like to calculate it, the liquid on the head, for example, we edit this head. Okay, and let's take a copy from that sketch here. Okay, and let's So from here, if we, that's the weight of this element, it's around 2 tons of liquid. That's the specific gravity. So if you would like to define the specific gravity, you can, as we discussed, you can define it here. So let's change it like that. Okay, so if we calculate the weight, it will be 1 ton.6 around that value here. That's the weight of the. So you can calculate it by that way right now. But we are planning to add the liquid level on as
Why
another.
I'm asking you, why I'm just raising this, Ahmed, because these are very important parameters. The weight which we define in our drawing, which we show on our
Yes,
drawing, that
but
operating weight, internal weight.
the design tools calculated that. Or if you are using compress or you are using VVLF, you will calculate that easily. Yes. You can calculate the weight. It's easy to
Yeah.
calculate it.
From there, of course, from there we'll get it. But suppose some draftsmen, they are preparing this drawing. Normally, they are doing the isolation, and sometime on the drawing part is there in the scope, and they want some weight. So that's why I just raised this question, because those who are knowing inventor, for them it is okay. From there they can calculate. But those who are not aware of the inventor and they want just to use the software, it will be difficult for them. But it's good. I think you should just take in consideration in your next
Sure,
version
we are
that
planning to
something,
do
yeah.
like before we
And that will be a cross check, and that may be a cross check to some other software which we are using, because weight plays very important role in our all vessel drawing and everything. It's okay. That's
here are
fine.
some other options I forgot to for you, like some standard blocks like the north direction. If you would like to have north direction, nozzle fluids, some
Okay.
standard blocks here. You can add it. Some tables like the weight summary table. Okay, and you can fill the weights from here in area rating. Okay, from your design tool, so you can.
Okay. Yeah, weight
And
summary.
anytime you would like to modify it, just fill it and
Okay, that can be done. Okay, fine.
Okay. Foundation rules, table for foundation. So you can add it like that, and from annotation, let's add general table. Here, and define that as the foundation load on the exit saddle.
Got it. Okay.
And the sliding saddle the same. Another for the ASME nameplate. Okay, and you can define the values. For example, let's move to so you can get this nameplate, and if you would like to modify the scale, just from here. If you would like to move it like that, and the data will be different. Okay, those are some options for drawing, and let's show you some real projects created by SEG from here.
One more question is there, Ahmed. Just can you tell me whether inclined vessel, sometimes both the saddles are not the same. We are having a lot of cases where the saddles are not same because it is inclined heat exchangers, inclined vessels. So that can be done in this.
I cannot understand your question. Would you mind
Inclined
to say?
vessels? Yeah, inclined vessels. One side up, slope up in the shell.
Yes, I got your point. Here in SEG, we have an SEG helper. If we open this helper, Sorry, I will check this. In the SEG helper, you will find the sloped saddles for the sloped vessels, or to suit the vessel with inclination, and you can add, or it includes some of cranes, lifting cranes, shackles. So this helper, you can use it. I will show you one video for that. Here, by using the helper, we make this simulation, and the helper, it's including the some standard cranes for DMAG, TRX, and Mantok companies. And here, by using this, we make some simulations for real cases. That's an desalter unit with 5 meters diameter and 40 meters length. Okay, and we make this real simulation by using the SEG helper tools, which including the cranes, lifting shackles. Okay, here we change the location of lifting wires. That's one of our studies. We study to lift this desalter over the pipeline. Okay, but in that case, we asked the company to make a shutdown for the pipeline, and we make two proposals. One of them by lifting over the pipe rack, and that's the second proposal by lifting below the pipe rack like this, and moving. We change the location of wires. Here, after that, we lift it over the here, and now we will install it on the foundation. After getting it to the place, that's the first desalter. We have two desalters, one in this area, and the second one will be in this area. And here the second desalter. As you can figure, that's the first. So by using the SEG helper, you will find a lot of standard elements. You can use it to make things easy for you.
So this simulation is inbuilt in your software in helper. That is what I understood, isn't?
Not
the simulation.
Creating on Autodesk Inventor by using SEG helper too.
Okay. Okay.
This helper includes those items. Okay.
Okay. Okay.
Okay. Let's open another one of our projects.
If you can just open some storage tank related, especially the roof, then it will be, because we are in the need of some software, because of some project we are expecting in near future. For that, we are just looking for any software which could help us in doing the drawing very fast. So if you can just tell us what the storage tank, your software covers what part of the storage tank, whether we can have the plate cutting diagrams and all.
Okay. Now, after this visit, I will show you one of the storage tanks. Here we have this vessel right here, including diagrams like that. All of that needed on this.
Okay.
Now I will show you the drawings here. We will open the drawing. That's the drawing.
Yeah, very good.
4 sheets.
Yeah.
That's the general arrangement drawing, and that's the nozzle table. All of that, as we discussed,
Okay.
is generated
Okay.
automatically.
Okay.
You will need to add dimensions and applications. The bill of material is the same, it's generated automatically.
Okay.
Here, the internals. The same for the saddle and the nameplate. Here, let's put in the saddle. Here, that's the saddle detail, the nameplate detail. Okay, the pipe support detail. That's it. Okay, so that's a real project for, we did it for one of
This is
our
good.
customers. And let's open storage tank drawing samples. But I think the storage tank project is not the final one.
Okay.
Because it's created on another. But we take a copy without drawings. Maybe I will check with you. Just it's saving the last project.
Santosh, do you have any queries? Then please come up with that.
Okay, let's open this. So that's a real project. So let's hide the structure. That's the plates of the roof and plates of the bottom. So what is your question regarding to the roof plates?
Roofs structure, different type of structures we are using for roof, and some are from outside the roof, some are from inside the roof. So what type of roof structures?
Regarding to the roof structure. So your question.
The roof structure.
No. SEG not focus on the structure, because we are focusing on the statical component. We make a simple roof structure as a one case, so you can use it if you have a simple roof structure. So we make it to make it easy for our customers. But for complicated roof structures, you will need to make it on Autodesk Inventor itself by using frame engineering or any other tool. You can make it using Tekla or any other. But here, SEG focusing on the static component itself, not on the roof structure.
Okay. So one more question for storage tank, and I think that is the last question for storage tank. Plate cutting diagram. We need a plate cutting drawing for to issue to the site for the cutting of the plate. Whether it gives us the plate cutting drawing, showing the number of plates required to build this tank.
Yes, sure. Here,
nesting of the plate, basically.
The nesting, you will use the nesting tool of Autodesk, but let's discuss point by point. Here, if we take a look to the elements here for the bottom plates. Okay, you configure that those are the bottom plates are like that, and if you have two plates looks like each other, you configure that SEG will sum them in one element to give them the same item number, like we discussed on the ellipsoidal head and shell plates like that. And those are the roof plates, and we have 28 identical plates with the length of 6 meters and 2 meters width and 6 millimeters thickness. Okay, so SEG can take care about this. So if you would like to make a flat pattern for the shell plate, we open the update plate. That's the plate arrangement of the roof. If we open the flat pattern, if you would like to create the flat pattern of a roof, let's create it from here. Will takes 1 or 2 minutes to generate the flat pattern of the shell. As you can figure that you have the overlap between plates.
So this is by default the plate size considered by the software, or we need to enter the size of the plate?
As we discuss on the presentation, you will need to define the delivered plate dimension.
Okay, that's good.
So those values calculated depending on the defined values on the delivered plate length and width. So it depends on your definition at the beginning.
Thank you.
After finishing, I will show you this option again.
Okay, sure.
Okay, now the assembly is done, and that black area is the slice cut. So you will need to make this cut, and to get the overlap, to get the conical shape of the roof. Okay, so if you get this line over that line and weld them, you will get the conical shape of the roof. Now to create a drawing for this, so let's create drawing. Select A1, select. So let's take a look from front view. So we'll need to take a look from the front view here. So it will be from the front view, and let's change the scale. Let's add a bill of material, and if you would like to add weld details, so let's add some weld details here. So let's add this one, overlap, build. Here that's the bill of material. Now the weld details will be added to the drawing. Now we will need to change the scale a little bit here. Okay, and that's the bill of material. And if you would like to add those plates on the drawing like that, you can add it by that way, like that. Okay, the same for the others. If you would like to make a nesting by using the nesting tool of the Autodesk, so if we come back to here and you would like to make a nesting by clicking on create nesting. Okay, but this step will take some time, maybe 15 minutes to generate it. You can see one video for that here. Here for the bottom plates, here for example, we will make a nesting for those plates like that. Okay, and the nesting tool will detect the elements, material, and thickness for each plate. Okay, after that, you will define the available plates in your stock, and the nesting tool will calculate the required number of plates like that here, and you can generate a report for the nesting by using the nesting tool of Disk. Okay, SEG will help you to get those items to make a nesting for them. Okay. Any other questions regarding to this point?
Yeah, this is very good. This is what I was looking for because it's consuming most of the time. Making this assembly and all will not take that much time as the nesting of the plates. So this is something I appreciate that it is there. Okay, no more question from my side. I'm done.
Yeah.
The questions. Thank you.
Thank you. Okay. Thank you, Mazan. Ahmed, thanks very much. Very good
You are welcome.
presentation.
Thank you for your valuable comment.
Yeah. So I have just only one question.
Yes.
Whether this can be integrated with PV Lite software, which we normally use for designing the static vessel.
Yes. Here I think Fauzan tell you about that. There is an integration tool between SEG software.
I believe we have done a couple of webinars also on that. PV Elite actually generates an access file. So whatever data is coming into that access file, SEG uses that access file, and with the help of the access file, you can directly take the 3D model from PV Elite to SEG, and from there you can go and generate a drawing. So whatever things will be missing in the access file can be remodeled in SEG. So maybe supports, if some supports are missing, or the tube details are not coming over here because PVLE doesn't provide the tube data, the tube sheet details in the access file, which is going to come shortly because many of our customers has raised a request that we need the detail access file from PVLE, which is under development and might come very soon actually. So which they have also accepted that we will be coming up with more detailed access file. So once that will be available, then SEG can able to provide the data for the heat exchanger as well. Right now, it is only taking the pressure vessel data, whatever the PV Elite can provide, and that data can be imported directly into SEG.
Okay. Yeah.
And we have couple of videos also available on related to the interface of PV Elite with SEG, and we have done webinar also on that. So I can share you, and you can go through that as well.
Yeah. So please send me the link of those videos so that we can go.
Yeah, sure. I'll do that.
One of them here, those running videos, we exported the access database file from this this vessel and create this equipment. After that, we make some modification and make some customization for some elements, like adding here. That's the same model, but after that, we make some modifications to the saddle, to the manhole, add some Davit and bolts to the nozzle. So you can check those videos. We have on our channel. You will find a lot of videos regarding to that in detail.
You can subscribe to the channel, which is Ahmed Hegazy channel is there for related to SEG. So lot of videos are there which can help you to know each and every module of the software. We have done tank complete detailing from scratch. So we have prepared 2 videos also for that. So that will also going to help you in knowing the entire module of the software while designing the storage tank using SEG as a software.
Okay. Yeah. Good. Thank you. That was my question. And just small last question: whether inventor is mandatory for having this software operative?
Yes, like CADWorks and BricsCAD or AutoCAD. In this case,
like how you are using CADWorks on top of on Bricks, you are using CADWorks on top of AutoCAD or BricsCAD, right? So similar to that, SEG works along with Inventor.
Okay. Yes, and we are working on another project right now to make it runs on SolidWorks.
We have ZWCAD along with AutoCAD licenses. So we don't have Inventor license. So my question is whether this will work without having Inventor.
At present, Inventor is mandatory to run SEG. And in the future versions, we are coming up with SEG running on top of BricsCAD. Right, Ahmed?
Okay.
Yes.
We are already, the discussion is going on between Hexagon and SEG, where the 2 teams are interacting with each other and they are trying to develop a software or SEG which will work on BricsCAD platform.
Okay.
So which will also have the direct interface with PV Elite. So that is going on and it is under development. So obviously that will take time, because this year I believe Ahmed and the Hexagon team has started working on it. So right now Ahmed is getting more familiar with the BricsCAD functionalities and all, and then he'll start developing the software which will work on BricsCAD. But right now it is working on Inventor. So Inventor is mandatory.
Yes. Okay. Yeah. Thank you. Thank you so much.
You're welcome.
That's all.
Thank you for your valuable time.
Any more questions, team, or shall we end this session?
I am finished with.
Okay, fine. So, Muzammil sir, I hope you are also done, right?
Yeah, I'm done. Thanks a lot, Ahmed.
Okay.
Thank you.
So thanks everyone for your valuable time.
Thank you.
Thanks Ahmed for the wonderful presentation.
Thank you.
Thank you and have a great day. Bye.